So the first person who would be showcasing is Sukrut, and his project was called the Line Following Vehicle. Sukrut, are you with us right now?
Yes, ma'am.
Yes, thank you, Sukrut. I'm going to add you to the spotlight and also give you permission to share your screen in case you want to do the showcase.
Yes, ma'am.
You will have 5 minutes to showcase your project. Please try to keep it concise so that we can give a chance to everybody to showcase and also have the Q&A session at the end of it.
Okay.
Please go on.
Ma'am, can you view my screen?
Yes, we can.
Okay. Good afternoon, everyone. I'm Sukrut Chandra, and today I'm going to talk about the story behind my tech, the line following vehicle. Nowadays, we have seen several road accidents where drivers lose their control over their vehicles, depart their lanes, or crash onto the divider, or even jump over the divider and crash onto the opposite direction traffic. This problem was resolved in the ADAS Level 2, which has been implemented in several new cars in India. This system basically identifies the white or yellow lane boundaries and pushes the vehicle back onto the lane whenever it tries to depart the lane. The model I'm showcasing is a small prototype of the same system. So let me tell how I made the prototype. For this, let me talk about the structure. I used a lightweight wood material for the structure of the car. The main circuit, which was the motor driver, was mounted on the rear part of the car. The car was powered by two motors connected to wheels on either sides of the circuit. For the detection of the boundaries, I used two IR sensors mounted on the front part of the car. The car was also supported by a ball bearing in the front. Now let me talk about the circuit and how the system worked. For the circuit, I used two IR sensors, two motors, as I already said, and a motor driver with the L293D IC, which was powered by a 6V battery. So, when the IR sensors sense the lane boundaries depending on their color, they send different signals to the motor driver, enabling the motors. So basically, if one IR sensor sends the boundary, it sends a certain signal to the motor driver, which powered the motors. So depending on that, one of the motors was switched on and the other was switched off. Due to this, the car used to turn away from the lanes. So this is how basically the system worked. So for the demo, I used a black boundary as the lane boundary, which was like I used a garbage bag for that. And the final model was inspired by the theme for the Republic Day this year. I also mounted a flag onto the car. So now let me show a video of the working. Thank you.
Thank you very much, Sukrut, for sharing that with us. Judges, if you have any questions, shall we take it now with the students or shall we do it at the end of the 3 showcases? How would you like to do it? We have it open. In terms of feedback, in terms of questioning?
Maybe we can do it now because the memory will be fresh.
Yeah, that's true. So we can do the feedback. We can have about 2 minutes of feedback for everybody, 2-3 minutes, and then we'll move on to the next showcase. So yes, please, any of you, if you have questions, feedback, please go ahead.
Sure. I can start if that's okay. Yeah. So Sukrut, very interesting project. So how did you make the wood panel?
So I used the motor driver was from a kit, so I used the wood panel from the kit.
Okay, yeah. Why do you think the car is when it encounters a boundary, it makes a 90-degree angle, right? So it is like always going in the form of a square.
Yes.
What would you change in your setup if you wanted to actually follow the circular path? How will you do it if you want to
Probably
always go?
I would make like the wheels also turn. So it was not possible in this, in this prototype. So if the wheels could turn like the real cars, like where you can steer the front wheel, so that could be better. Probably.
Yeah, that will be very interesting. I think you should think of that. So next version, you can try that, and also learn if you have already learned all of this. Also learn Tinkercad. Have you heard about Tinkercad?
Yes, I have heard about Tinkercad.
So you can use Tinkercad to actually make your frame also, and that way you have a lot more flexibility in what you want to do. Your electronics is already, you understand what electronics, how to handle the electronics. Now also start designing. That will be a very nice step up. Yeah, very interesting project. Yeah.
Thank you, sir.
Yeah.
So, Sukrut, wonderful project. I really liked your idea and the way you have put together things. And the future is going to be autonomous cars and so on. So this kind of technology is going to be very useful and very futuristic. So I really appreciate your efforts and kudos for putting the Indian flag. I really like that and the top you chose. Now coming to the project execution, I really liked it. So just tell me, like your lane assist system, this car that you have designed, this has sensors. So how did you choose the sensors? How did you pick out the sensors that these are going to work for my technology?
So IR sensors are like the best and the most efficient for this kind of like small scale, and also like it works good for the. So it's basically dependent on reflection. So the like colors like black like reflect more, and colors like white colors like black reflect less and white reflects more. So here I think IR sensors was the best option because it's like on a small scale it's good, and it's also more efficient.
So coming to that, like you're saying with the black and white, so how did you decide? So what kind of contrast does it have to see? What limits, like if the contrast reduces to a certain extent, like you are right now, you had a black and white, so best contrast possible. But on the roads, sometimes you have yellow marking, even very faded marking. So how will that be affected? Have you
So the faded, if the marking is faded, then of course the system won't work. So
did you try your prototype with a lesser contrast?
no, there is actually a variable resistor where you can actually tune the color. So if you can change it, you can change actually the color you would want to go away from the lane boundary color basically.
Very good. And the next question, anyway, the Shrikant already asked about, like it's moving not in a very systematic circular motion, so it's just having some jumps. So you should think about it, like to how to smoothen it. But otherwise, a fantastic project. Keep it up. Keep doing good.
Thank
All
you.
the best.
So Sukrit, again, awesome project. Really loved it. And loved the way, you'd put it together. Okay. So you said that you told us what the applications are. Now, could you also think of some limitations of this? What would be the issues of the system, assuming the system is working perfectly?
So the issues might be like if the if the lane boundary is not colored or if it is faded, the system won't work. So as
No,
long
won't work is a different thing. So that you know how to fix it, right? But can you think of a couple of use cases where it's working perfectly and that's still a problem?
So basically, when driving, so if the driver is intentionally changing the lane, so it can be a bit annoying. That's it. Otherwise, it's like not that much a problem.
What about if it comes across, our roads, right? What about if it comes across a pothole, not a pothole, but like a place where they've fixed the road and therefore the color is different?
So it depends on what the color is. If the color is near to white or the lane boundary color, of course there might be a problem. But usually when I've passed, it won't look like white. So I think it won't be that much of a problem. So of course, if it is white, then yeah,
Hmm.
it will
Okay.
be a big problem for drivers.
Right. And so this works with cars which have the motors and the wheels, right? So can you also think of, suppose the road is like pretty narrow and it still has markings on both sides. Would this cause some kind of instability in the car?
So it is still up to the driver to control the car. So the driver also has to be careful. So if the driver is not careful and he keeps trying to departing the lane, of course it will cause an instability. But see, it's not like fully autonomous. So the driver also has to be like careful not to go onto the divider or depart the lane. So if it is too narrow, then it will still save the driver. Like it won't allow him to crash on the divider, but yeah, it will cause instability.
Okay, cool. Yeah, so we could think of a version, for example, where it prevents you from getting to the divider, but so there's a very bright marking or something at the divider, but the contrast, the rest of the road maybe is not that much, some such thing. So it's not exactly lanes for Indian situations. I'm saying, right? Something like that is what you're saying. Is that right?
Yes.
Okay, great. Yeah, thank you so much. But
you.
awesome, and really glad that you've thought through it so much.
Thank you.
Thank you so much, Sukrut, for that. I have not seen any of the projects before this because I wanted to be completely unbiased. I do have a few questions and a few suggestions. One, I think we have covered most of it, but you will face issues when you have a reflective surface like a garbage bag out in the sunlight. So you probably ought to think about how to remove the reflections because IR doesn't work. I have seen enough of these projects where the IR, you will have to think about how you can modify the structure so that the IR can still make out the contrast in bright sunlight. You will need to have non-reflective surfaces. So you can think about those things or whether you need to have a blinder for the IR. Number two is you were not using any microcontroller, or were you?
No, it was
Have you
not a
used?
microcontroller actually.
Yeah.
It was a
So
motor
if you
drive.
Yeah, so if you use a microcontroller, you also get more control where you can
Yes.
control the speed of the wheels rather than just the direction of it. So that could be a nice next step for your project. Outside of that, very well done, very nice, interesting. Any good project, I believe, is also where you have thought of the pitfalls. No project is perfect. And what makes a project very nice is where you think about where it could fail and start working from there.